This is the first lithium iron phosphate battery in the world capable of delivering 652 miles of range, and it's already being used in an electric vehicle. Yeah. For years, the electric vehicle industry has been dominated by what felt like an almost unchangeable assumption: if you want extremely long range, you have to use nickel-rich lithium-ion batteries like nickel-manganese-cobalt or nickel-cobalt-aluminum. Tesla typically uses LFP batteries for the standard versions of the Model 3 and Model Y. They're a cheaper, more durable, and safer option, but the trade-off has always been lower energy density and shorter range. That's why when an LFP battery was tested in a car and managed to travel 652 miles, the first reaction from many people in the industry was skepticism. It seemed to contradict the entire engineering logic that has guided more than a decade of EV development. So how did this LFP battery manage to do it, and how could it change the game for EVs? Yeah, what's happening with BYD's new generation Blade Battery? An LFP battery that already has a strong reputation suggests that the old assumptions may finally be breaking down. To understand why this is so shocking, we need to look back at the role LFP batteries have played in the history of EV development. For many years, nickel-manganese-cobalt and nickel-cobalt-aluminum batteries were considered the gold standard for premium electric vehicles. These battery chemistries allow for higher energy density, meaning the same amount of battery mass can store more electricity. That directly translates into longer driving range, a key factor in convincing consumers to switch from ICE cars to EVs. In contrast, as we mentioned earlier, LFP batteries have mostly been used in budget or mid-range EVs. Their advantages are lower cost, longer lifespan, and superior safety. But their biggest drawback has always been lower energy density. That means to achieve the same range as an NMC battery, you would typically need a larger and heavier battery pack. As a result, LFP has long been seen as the economically sensible choice, but not the performance-optimized one. To change the way the industry views LFP batteries, BYD developed the Blade Battery, a revolutionary LFP battery design. Instead of using the traditional block-style battery cell structure, the Blade Battery uses long, thin cells shaped like blades. These cells can be arranged directly into the battery pack structure without relying on many intermediate modules. This design significantly reduces the number of non-energy storing components inside the battery pack, which increases energy density at the system level, even though the underlying LFP chemistry itself hasn't changed dramatically. However, BYD's latest breakthrough seems to go even further than the original design. Data from new models like the Denza Z9 GT shows that the driving range under the CLTC standard can exceed 1,000 kilometers, or about 652 miles. That's a figure that previously only appeared in electric vehicles using extremely large NMC battery packs, or, in some cases, hadn't even been achieved in real-world conditions at all. What's interesting is that the battery capacity of this car isn't extraordinarily massive. The pack is around 122 kilowatt-hours, okay. Large, but not unprecedented. Many high-end EVs have already used battery packs in that range. So why has the driving range increased so dramatically? Okay, there are three main factors to consider. The first factor is the overall energy efficiency of the system. An electric vehicle doesn't rely only on the battery. It also depends on the motor, the energy management system, aerodynamics, and the vehicle's weight. BYD has been steadily optimizing the entire vehicle architecture, including the use of gigacasting, a manufacturing technology that casts large sections of the vehicle frame as a single piece. This reduces the number of parts and lowers overall weight. When the car is lighter and the structure is more rigid, energy efficiency improves significantly. The second factor is improvements in the battery structure. The new Blade Battery can utilize space more efficiently, reducing intermediate components and increasing the proportion of energy-storing materials. This means that even if the energy density of the individual cells only increases slightly, the energy density of the entire battery pack can rise substantially. The third, and perhaps the most intriguing factor, is advances in thermal management and battery chemistry. BYD claims that the energy density has increased by only about 5%, yet the driving range has improved by 20 to 25%. That has led many experts to wonder, could there be deeper improvements in the material structure or battery management system that the company hasn't publicly disclosed yet? If these numbers are widely confirmed in real-world conditions, the impact could be enormous. For years, consumers have worried about range anxiety, the fear that an electric car won't have enough range for long trips. But when an EV can travel over 1,000 on a single charge, that concern almost disappears. Not only that, achieving such long range with LFP batteries, which are cheaper and more durable, could completely reshape the cost structure of electric vehicles. Instead of relying on expensive materials like nickel and cobalt, manufacturers could use more affordable battery chemistries while still achieving comparable performance. In other words, what BYD may be demonstrating is an interesting paradox of technology. Sometimes the best solution isn't inventing an entirely new battery chemistry, but optimizing a technology that already exists. If the 652-mile range of the new Blade battery has already surprised the tech world, the rest of the system's specifications are even more astonishing. So, how incredibly fast can this LFP battery charge? If you search for the keyword BYD battery across different platforms, you'll notice that the new Blade battery is attracting huge attention for its 5-minute charging time. Even more impressive, when charging in extremely cold conditions of minus 30 degrees Celsius, it reportedly takes only about 12 minutes to reach 97%. You might not have noticed this, but in the EV industry, long driving range usually comes with a familiar trade-off: longer charging times. The larger the battery pack, the more time it typically takes to refill it with energy, and for a long time this has been considered an unavoidable limitation of EVs. However, BYD seems to be trying to break that rule as well. According to the published test data, the new Blade battery can charge from 10% to 70% in about 5 minutes, and from 10% to 97% in just a little over 9 minutes under normal temperature conditions. That places BYD's charging system among the fastest in the world. For years, EV manufacturers have been trying to reduce charging times to under 20 minutes for the 10 to 80% range. But BYD is talking about something entirely different, almost fully charging a battery in under 10 minutes. This charging speed is far faster than the 20 to 40-minute charging times seen in many of the latest EV models in the United States. To understand how impressive this is, you have to look at the charging power required to achieve those speeds. BYD is developing ultra-fast 1,500 kilowatt charging stations, far exceeding most systems available today. Most DC fast chargers on the market currently deliver around 150 kilowatts to 350 kilowatts. Some of the newest systems are experimenting with 500 kilowatts, but 1,500 kilowatts represents a truly massive leap forward. Of course, charging speed doesn't depend only on the charging station, it also depends on the battery's ability to accept current. A typical battery pack, if charged too quickly, will generate significant heat, which can degrade battery life or even create safety risks. So to achieve such extreme charging speeds, BYD has had to improve multiple aspects simultaneously: electrode materials, cell design, the battery management system, and the cooling system. One of the key factors may lie in BYD's distinctive blade-shaped cell structure. These long, thin cells not only optimize space, but also allow heat to dissipate more efficiently compared with traditional cylindrical or prismatic cells. When large electrical currents flow through the battery during fast charging, the heat generated can spread more evenly across the cells. This reduces the risk of hotspots, one of the main causes of battery degradation. But what truly surprises many experts isn't the charging speed at room temperature, it's the battery's ability to charge in extreme cold conditions. In one published test, the new Blade battery was able to charge from 20% to 97% in about 12 minutes at minus 30 degrees Celsius. For the battery industry, that number is almost unbelievable. The performance is remarkable because traditional lithium-ion batteries charge very slowly in extreme cold. Freezing temperatures slow down electron transfer inside the battery, which significantly affects charging performance. To understand just how unusual this is, it's important to remember that most lithium-ion batteries, including both LFP and NMC, perform poorly in cold weather. When temperatures drop, the chemical reactions inside the battery slow down, and lithium ions move more slowly between the electrodes. This dramatically reduces charging speed, and in many cases the battery management system will even limit fast charging altogether to prevent damage to the battery cells. In fact, at around minus 20 degrees Celsius, many current electric vehicles can take dozens of minutes just to begin a stable charging process. Some systems even need to preheat the battery before fast charging, which significantly increases waiting time. That's why a battery pack that can charge almost to full at minus 30 degrees Celsius, and do so only about 3 minutes slower than at room temperature, is something that has rarely, if ever, been seen before. This suggests that BYD may have achieved significant advances in thermal management and electrode design. One possibility is the use of new materials that reduce the battery's internal resistance, allowing ions to move more easily even at low temperatures. In addition, an integrated battery heating system may also play an important role in maintaining the optimal temperature during charging. Fast charging and cold weather performance aren't the only improvements in BYD's new generation of electric vehicles. What many people may not realize is that China has also introduced some of the strictest battery safety standards in the world. These regulations require automakers to ensure that a battery does not catch fire or explode for at least 2 hours after a single cell goes into thermal runaway. If a battery fire does occur, Chinese automakers are even experimenting with unusual engineering methods to protect both the vehicle and its occupants from the effects of a battery fire. So, BYD says its new Blade battery complies with these stricter standards, demonstrated in videos showing multiple nail penetration tests performed on the same battery pack, and the pack appears not to catch fire. Alongside its battery technology, the company is also transforming the entire architecture of vehicle manufacturing. One of the most notable changes is the adoption of gigacasting, a method of casting large sections of the vehicle frame as a single piece. Gigacasting first gained widespread attention in the auto industry when Tesla began using it for some of its vehicles. This technology allows manufacturers to replace dozens or even hundreds of smaller metal parts with a single cast structure. The result is lower weight, greater structural rigidity, and a simplified manufacturing process. BYD is now beginning to apply this method to its newer models, and it brings several advantages. When the vehicle frame becomes lighter, the overall weight of the car decreases, which improves energy efficiency. In practical terms, that means each kilowatt-hour of electricity in the battery can take the car farther. In addition, redesigning the vehicle structure also brings practical changes for users. Some of BYD's newer models now feature larger cargo space, and even include a front trunk, something many of the company's earlier models did not offer. These changes show how the combination of mechanical design and battery technology is creating an entirely new generation of electric vehicles. When all of these elements are considered together, a driving range of over 652 miles, the ability to charge almost fully in under 10 minutes, stable performance in extreme cold, and a lighter vehicle architecture, the overall picture becomes clearer. BYD isn't simply improving a battery pack. The company is optimizing the entire electric vehicle ecosystem. From the battery cells themselves to the vehicle structure and even the charging infrastructure. In recent years, BYD has been taking batteries more seriously than any other automaker. Tesla used to focus on batteries, but since they developed the 4680 battery, they've largely ignored other battery types. If BYD's new Blade battery represents a major leap in performance, range, and charging speed. Another battery technology the company is developing aims at a completely different goal, drastically lowering the cost of EVs. Yeah, that technology is the sodium-ion battery. Sodium is an element that is extremely abundant in nature, especially in sea salt. This means its supply is far less constrained than lithium. Even though lithium prices have been dropping recently, they can rise again at any time, and historically, lithium prices have been highly volatile. Another important advantage is that sodium-ion batteries don't require expensive metals like cobalt or nickel. However, for many years, sodium-ion batteries were considered a technology that was promising, but not quite good enough. The reason lies in a fundamental characteristic of this chemistry: sodium ions are larger and heavier than lithium ions. So what does that actually mean? In fact, a sodium ion is more than 3 times heavier than a lithium ion. This creates 2 major challenges. First, sodium batteries typically have lower energy density, meaning that for the same battery weight, they store less electricity. Second, the larger size of sodium ions makes it harder for them to move through the structure of electrode materials, which limits the overall performance of the battery. These 2 limitations have made sodium-ion batteries difficult to compete with lithium-ion batteries in applications that require high energy density, such as electric vehicles. Most research efforts have only achieved around 100 to 120 watt-hours per kilogram, which is significantly lower than modern lithium-ion batteries. However, BYD says its new sodium-ion design can reach about 175 watt-hours per kilogram, which represents a significant step forward compared with earlier efforts. While this figure is still lower than high-end NMC batteries, it is already sufficient for many types of electric vehicles, especially urban cars and lower-cost models. More importantly, BYD isn't focusing only on energy density. The company has also addressed several key technical challenges that previously slowed the development of sodium-ion batteries. One of them is sodium plating during charging, a phenomenon that can reduce both performance and battery lifespan. Through improvements in materials, including the use of stable polyanion systems, BYD says it has significantly reduced these issues. The result is a battery system with extremely high durability. In laboratory tests, BYD's sodium-ion battery can reportedly reach up to 10,000 charge and discharge cycles. That figure far exceeds many lithium-ion batteries currently in use. For nickel-rich NMC batteries, lifespan typically ranges from about 1,500 to 3,000 cycles under ideal conditions. LFP batteries are more durable and can reach around 4,000 cycles. But even that is still far below the 10,000 cycle target that BYD is aiming for. If these numbers are proven in real-world use, the impact could be enormous. Imagine an EV owner who charges their battery from 20% to 80% every day, a common habit used to preserve battery life. With 10,000 cycles, that vehicle could theoretically operate for more than 25 years before the battery reaches its cycle limit. In reality, many people don't charge their cars every day. If charging only happens every 3 or 4 days, the theoretical lifespan of the battery could stretch for decades, possibly even approaching a century. This leads to an interesting consequence in the future. The battery might no longer be the fastest-wearing component of an electric vehicle. Instead, mechanical components such as the suspension system, electric motor, or even the vehicle frame might need replacement before the battery experiences significant degradation. That would mark a major shift from the common perception today, where many people worry that EV batteries will need replacement after only a few years. According to several industry estimates, when produced at scale, sodium-ion batteries could reach a cost of around $19 per kilowatt-hour. For comparison, LFP batteries today still cost roughly $60 per kilowatt-hour. If that price becomes reality, it would reduce battery costs to about 1/3 of current levels. So what does that mean for consumers? Simply put, electric vehicles could become significantly cheaper. A small electric car in the future might cost around $15,000, yet still be durable enough to last for decades. When that happens, EVs will no longer be seen as high-tech products aimed mainly at early adopters. Instead, they could become true mass-market transportation, especially in developing markets. In other words, if the Blade battery helps EVs achieve impressive performance and driving range, then sodium-ion batteries could accomplish something just as important, bringing EVs to hundreds of millions of new users around the world. In the end, everything we've analyzed points to one very clear conclusion. BYD isn't just improving EVs. They are redefining the future of batteries. From the next-generation Blade LFP battery, capable of delivering over 1,000 kilometers of driving range and charging almost fully in just a few minutes, to sodium-ion batteries with extremely low costs and lifespans reaching tens of thousands of cycles. All of this reflects a long-term and deeply serious strategy focused on battery technology. And today, BYD has also become one of the world's leading automakers. If what we're seeing today continues to develop in the right direction, the future of electric vehicles could look very different from what we once imagined. Yeah, EVs could drive as far as gasoline cars, charge almost as quickly as refueling, and even cost less than internal combustion vehicles. And when that happens, the transition to electrified transportation could move much faster than most experts have predicted. We're really curious about how other automakers feel as BYD keeps introducing such impressive battery technologies. If you found this video interesting, please like the video, subscribe to the channel, and leave your thoughts in the comments. Do you think BYD's Blade battery and sodium-ion batteries will make other competitors nervous? Thanks for watching, and we'll see you in the next video.